All right, listen up. Welcome to your Advanced Diagnostics briefing. Today, we're cracking open a really powerful tool in your JavaScript toolkits, Array.prototype.entries. I want you to think of it like a high-precision scanner for your data arrays. Let's get started.
So picture this. You're down in the cargo bay and you get a pad that just lists, dilithium crystals, medical supplies, Baser coils. Is that actually enough information? No way. You need to know where they are, right? The name of the cargo is only half the story.
And this slide shows you exactly what I'm talking about. Over on the left, you've just got a simple list of destinations. It's useful, sure, but it's pretty limited. But on the right, now that is a proper manifest. We don't just have the destination, we have its coordinate, its deck number. That pairing of location and data, that's where the real power is. So, how do we actually generate this kind of manifest? Well, we use a specialized tool that creates something we call an array iterator. The best way to think about this isn't as a static list, but more like a live data stream that's feeding you information one piece at a time.
Here's the official Starfleet Academy definition for you. When you call the entries method, it gives you back an array iterator. Its one and only job is to generate that manifest we keep talking about, pairing every single item with its coordinate, or its index, and then handing you this perfect sequence of index-value pairs.
Now, the command itself couldn't be simpler. You just call .entries right on your array. But, and this is the really crucial part, notice that this doesn't create a brand new array filled with those pairs. What it does is create the iterator object itself. It creates that live data stream that's now just sitting there, ready and waiting for your commands.
This right here is a really key distinction to understand. Your original array is just a static box of data. It just sits there in memory. The iterator, on the other hand, is completely dynamic. It's kind of like a ghost or a pointer that knows exactly where you are in that data stream, just waiting for you to ask, okay, what's next? All right. Theory is over. It is time for some live fire simulations. Let's see how this iterator actually performs in a real Starship environment. We're going to run it through two pretty essential scenarios.
First up, the Turbolift. The ship's computer needs to be able to announce both the deck number and the location name as it passes each floor. A simple array of names just isn't going to cut it. We need that full deck manifest.
This simulation really shows off the lazy nature of the iterator. First, we initialize it. See? It doesn't do anything yet. Then we manually ask for the next item, and it gives us deck 0, the bridge. Then it just pauses, waiting. When we ask again, it gives us deck 1, sickbay. It only gives you data when you explicitly ask for it. Okay, now for a more critical and honestly a much more common scenario. We're running a level 5 diagnostic on the warp coils. In this situation, we absolutely 100% need to know which coil is reporting a problem and what its efficiency reading is.
Now, manually asking for the next item over and over is fine for a little demo, but in a real diagnostic, you want to scan everything all at once. And for that, the most efficient protocol by far is the for.of loop. The for.of loop is just perfectly designed to work with these iterators. It automatically calls for the next item from the stream, it elegantly unpacks that index value pair into two separate variables for you, and it just keeps doing that over and over until the data stream is completely empty. It's clean, it's efficient, and it's totally automatic.
And there's our result. The diagnostic completes, and thanks to our iterator, the alert is perfectly clear and totally actionable. It's not just that a coil is failing. We know it is specifically coil number 2, and its exact efficiency is a critical 85%. That is precision.
So, let's debrief. Why is this modern protocol so important? Well, to really get it, we have to compare it to the early, kind of clunky protocols that Starfleet used to rely on.
Ah, yes, this is the old way, the classic for loop.
I mean, it works, but it's so cumbersome. You have to set up a counter, you have to manually check the array's length on every single iteration, and then you have to remember to increment the counter. That's a lot of manual bookkeeping. When you see them side by side, the advantages are just obvious. The old method is clunky, and what you're trying to do isn't immediately clear. But the biggest issue is the high risk of error. Those classic off-by-one bugs are a constant threat. The new entries method is just better. It's cleaner, its purpose is crystal clear, and it dramatically cuts down the risk of bugs.
So if there is one crucial point to take away from this briefing, it's this. The entries method gives you a direct, unbreakable link between the coordinate and the cargo, between the index and the value. It makes sure you always have the complete context for every single piece of data you're working with.
So, you now have command of this powerful tool. You can create and control these live data streams with incredible precision. The only question that's left is, what diagnostics, what systems, what amazing things are you going to build with it? Briefing dismissed.